Hello, this is heat load calculation part 14E. We're still working on our Vatilo House in Birmingham, Alabama airport location for duct runs and unconditioned spaces. This is worksheet G. We had already finished up step 1, step 2, and step 3, the base case, which are on another video, and the R value correction, width, and leakage rate correction, LCF. They were also in another video, so we're down to this point right here, which is the surface area adjustment for ductwork. Okay, this calculation here is pretty straightforward. It's the surface area. They've calculated so much surface area based upon the parameters that we have and everything like that, and it's adjusting up and down. If you get extra, that's more of a heat load. If you have less, that would be a bonus toward you for less of a heat load. So we're going to just look at this and see where they come up with some of these numbers here. Now this is our one that we're working on right here, and I have this fillable form here to fill out some stuff, and we'll run into a few more of these down here where you have to do both sides of it. It's kind of in between there. Excuse me. So let's just take a look at where they came up with some of these numbers, so it'll help you when you're looking and you're doing a J manual heat load for the duct surface area. So back to where we were originally, let's look at the Vatilo House in Gulf Coast Town, Texas. This is the Gulf Coast Town, Texas house, and we got a couple numbers here, and we just need to kind of figure out where they're coming from. So line 14, 15, 16, 17, 18, 19, these are basically everything in here is going to come from our table 7AE up here, 7A-AE. We'll be using those charts for this, and the information also comes from your survey/blueprint. So this is the blueprint. I'm going to bring it up here where we can take a look at the whole thing. And once again, your information for this is up here on the right hand side. Told us that we had R4 insulation, not sealed, and we're also checking it for sealed with R8. So most of our information is actually located here in the center. So we got most of our information right here. Everything that's up here on the top part, this is your supply side. Everything down here on the bottom part is just telling you about your return side. So let's look and see where some of these numbers, I'm going to slide this over so we can look at both of them at the same time. There we go. Let's make that a little bit bigger if we can. Slide this over. There we go. Okay, so like I said, everything up here is supply, everything down here is return, and of course all you have to do is look here on your chart when you're looking at table line 1 here, installed supply area. So everything up here is going to be supply, everything right here is going to be return. So looking at these numbers here, the total supply we got is 366, and that's where they got this 366 right here. So we're going to kind of work in tandem here. Let's see if I can get my chart back up here. So our first number comes from right there. And we need to get rid of this. So 366 is my total supply area. Let's see if we can stagger this a little bit. Okay. So line 14, 366. And of course, it remains the same on both sides, whether it's on this side or that side. Really makes no difference. I'll put the extra 0 in there just for fun. Okay, default supply area. Looking at the original, they have 143. Okay, this is going to come from your chart on table 7AE. Let's see if I can pull that up. So we're going to use the uncorrected version of this that I have set up because I've got some figures and everything on here. Let's make this a little bit bigger, and we're going to slide it over a little bit. So we're using this table right here. Now, as you can see over here, I've got a table that I made over 3,000 square foot, and I'm going to explain where they actually got these numbers. Now, you see this number here, 143. If you look on your chart for 1,000 square foot for supply, 1,500 square foot for a house, like I said, the supply is 177. Well, that's not 143. 109, that's not 143. Basically what they did is they kind of split the difference. And this number here, I remember it from the older table. This is actually off the old table, but we're going to find what it actually is for the new table. We need to figure out this supply. Now the problem is our house is 1,200 square foot. It is neither 1,000 square foot nor is it 1,500 square foot. So we're looking for a number that's in between 109 and 177. In other words, you have to find the percentage 1,200 is in between these two numbers, 1,000 and 1,500, and we figure out that it's 40% of the way, just like it was up here on your base case heat loss table, sensible gain table, and latent gain table. So we're still at 40% in between these two numbers, so that means we're looking for a number that is 40% in between 109 and 177. Now, if you need to learn how to actually find this number, you can look at the base case or the sensible gain factor videos or the latent gain videos. Like I said, any one of these videos right here, all three of them show exactly how to find this number. So we're just going to use what we came up with. So finding 40% in between both of those numbers, our default supply number for 1,200 square foot is actually 136.2. Our return, we still have to do the same thing. We need to find a number between 1,000 square foot column and the 1,500 square foot column. You got 32 on this side, 43. So we need something that is 40% in between these two numbers, which ends up being 36.4. That's how they came up with those numbers. The numbers they came up with, 143, that's actually based off the old chart. These numbers, I remember them being a little bit different, so that's why they ended up with a number that's a little bit different there. So for line 15 and line 18, you're going to have to find a number that's 40% in between these. Or like I said, if your house was, let's say it was 1,400 square foot, then you'd have to be like 80%. You see what I mean? Like I said, these are just default for 1,000 square foot spot on. Anything up or below that, there's going to be a deduction or you're going to have to add to it. But these are the numbers we're actually going to use right here, so we can go ahead and plug these numbers into our number. So instead of having 143 on our number in Birmingham, Alabama, we're actually going to have the 136.2. So 136.200. Okay. Next is our RS, installed area divided by default area. Okay, let's show how they came up with their number. So they had 366, and we'll bring a calculator up here so we can do a little math on this. So basically 366 divided by 143, and they ended up with a 2.59999. Okay, so we're going to do the same thing with ours. Slide this over, bring ours back over here. So we're going to have 366 divided by 136.200. And we come up with this big number here. Now remember, we're going to round up to the thousands. So 2, 7, so that's going to remain 7. So we're going to make our number, slide that over a little bit. We're going to make our number 2.687. So that's going to be our little correction factor that we're going to use. Next thing we're going to do is we're going to do returns. So the return numbers will be first their total surface area that they have. Let's get this out of the way for a minute. There we go. So looking at our returns here, like I said, our return footage, 70, and we're double checking with the original. The original they use 70, which is this number right here, our total area of return. So now we're going to put that same number in here because the distance has not changed. Okay. Now the default return, once again, we're going to use that new number that we found in between both. So ours will be 36.4. Do not use 32, do not use 43, use the 36.4. We want to be as accurate as possible. 36.4. There we go. And finally, all we have to do is do the math and default some of this. So basically, default area, like I said, our RR is going to be installed area, which is 70, divided by the default area, the amount that they allow actually for it. So 70 divided by 36.4 equals this big number here, and of course we're going to round to the thousandth, so 1923. 1.923. And there we go. Okay, how much of this can we actually transpose over here to this side? Like I said, well, basically everything here is transferable over to the other side. If we look at the original one here, like I said, this number is the same as 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 this, and of course the final number is the same as this. So all the way from the line 14 all the way down to line 19, we can actually transpose those numbers right over to the corrected. Now remember, this corrected is the R8 when we sealed it up, so we're looking to see how much better everything is. But like I said, the footages and the actual amount of ductwork in there isn't really changing. Now of course, if you change the ductwork, then you would actually have to redo all this just like a new construction. 70 on that one, 36.40, and finally 1.923. Okay. Alright, so we're pretty much done with this chart right here. Now we get to move on to the next one, which is our KS and our KR. KS and KR, you're going to find a lot of your information is right in here. And you got other areas over here where you got KS, KR. So basically, once again, we're going to use theirs first to show where did they get that number. So let's look at it. Let's bring that KS, KR chart over here a little bit more. Okay, so here's my little surface area, KS, KR, and this is the leakage rate. Your leakage rate is right up here. So we're going to use whatever number defaults into there for right here. So KS, that number, KR, they're using that number. Okay. So we're going to use the same because it's the same number, and we're going to use that for both of these. Now, on the corrected, like I said, you see it's a little bit different, but remember their leakage rate is different. So the leakage rate for it's going to be up here. But this is where they get the KS, KR number from. Okay, so we'll go ahead and put our KS and KR numbers in there because this is uncorrected. So we can put in 0.743 for this one and 0.257 for this one. Okay. Now if you wanted to, like I said, you can look at the corrected value, and the corrected value is 1224 right here. So we could go ahead, and we're going to go ahead and put these in here because we're right there at the chart. Why not? 0.771 for the KS and 0.229 for this one. 0.229. Okay. All right. Now we're on to surface area adjustment, heating and cooling sensible. All right. So we take a look back here and see where did they come up with this magical number right here. Well, you have this part in between here, and it basically tells you exactly what you need to do, and it's kind of like a little formula that you're going to have to do. Like I said, our KS line 20 times our RS line 16, so times this one here, and then we're going to do plus add the KR, which is right here, line 20, times the line 19, which is this one right here. Okay, so we're going to take these to kind of help us out and remind us exactly where we're pulling these numbers for. So line 16 is one of them, line 19 and 20 is the other one. So KS, KR, there we go. Got a little marker there so we don't get them confused with some other kind of magical thing we're doing. Okay, so there we go. So basically all we got to do is multiply this times this, and then add it to what we multiplied this times this. So we're going to multiply everything first. So we'll bring the calculator up, and we'll do the first part here. The KS, line 20, times the RS, line 16. KS is right here, so clear the calculator out, 0.743 times this number right here, the line 16, 2.59, okay? 2.59. There we go. Okay, so I'm going to write this number down. Let's just bring this up a little area and we can write this down on. So we got, oops, there we go. It's always something in the way. 1.0.9013337, and I'm terrible drawing with a mouse. Okay, now we'll do the second part. So that's the first thing, and then we're going to add the second part once we get it. So their second part, where did they come up with this number? Line 20 KR, that's this right here, 0.25, 0.257 times line 19, which is right here, line 19, 1.867. So multiply those two together, and we get these numbers right here. Let's go ahead and write that down on our magical worksheet that we're doing. So now we got to add 4, 7, 9, 8, 1, 9. Okay. We're just going to add these two together. That's a terrible addition symbol. So 1.90137 plus 0.479819. 2.38. You could round that up, and that'd round that one up. This is not going to round up, so 2.381. That's what we're looking at right there. Let's go back and see 2.381. There you have it. So that's how they came up with that value right there. So there you go. So we're going to do that on both of these for R's now. Let's bring up our magical worksheet, and I'm going to erase this and reset our little drawing board here, so that way when we do our addition table, we'll know what we're doing. Okay. All right, so we can kind of move this one out of the way for right now. We want this one right here because we're going to use our values that we got because we know we had a little bit of adjustment on our surface area and everything like that. So same steps. This number here, which we're on this one right here, but I'm going to move this arrow just so I can remember which ones I'm actually pulling the number from. And I'll use this other arrow and flip it around just like that. There we go. Now I know which ones I'm using, so I don't get confused. All right, 0.734, 743, excuse me, 0.743 times 2.687 equals, okay, we'll bring this up, 1.99641. Okay, then we're going to add whatever we get to this one right here. Okay, now we're going to multiply this number here, 0.257 times 1.923, 1.923, and we get this number right here, which we're going to write down, 0.49411. Okay, now we just need to add these two numbers together. 1.99641 plus 0.494211. Okay, and equal that up and everything and see what we get. 2.49, and that will round up to 0. That'll round up to 0. Okay. So let's just bring that up here and go from there. Okay, put that right there. 2.491. All right. Now we'll do the same for this side over here and then move on to the next step. So let's reset our little drawing board here so we can write our numbers down. Know what to add together. Scratch paper is great on some of these calculations. So, you know, and I'm doing a lot of this just so, you know, for show, so that way you can see what you're doing. But I mean, you can move a whole lot faster if you're doing this all by yourself. All right, so we're going to take these same kind of numbers here and we're going to pull them from the corrected side over here, which is also identical. These numbers here are the only one that changed. So we got this number times this number, 0.0771 times 2.687.687, and that equals that number. And I'm going to write that down. Here we go. 0.207167. Okay. All right, back to our calculation. This number here times this number right here is 0.229 times 1.923. We get this number right here. Okay. So since we got this number right here, I'm going to make a little easier step. I'm just going to go ahead and add this number here to it. 0.207167. And there you go. So there's our number, and of course we're going to round up to the thousandths place. So that's going to round up to 8. So 0.648 is the number we're going to use here. All right, and there you go. Now you can see how much this adjustment factor really made a difference. This was our leaking non-sealed ductwork with R4 insulation. versus the correction factor with it sealed and R8 insulation. It made a huge difference on it. Like I said, so, you know, and just put it into perspective, if you had something like 4, just the number 4, if number 4 times this number right here, you can see it's going to be pretty big. In fact, let's just do that. If we had the number 4 and we times it times 2.491, you get that. So we can just think of that as like, we'll just say that's thousands of BTUs it's adding right there. Okay, that's 9,000 BTUs. I mean, that's over half a ton. Amazing. All right, now we got the corrected factor. So same thing, 4 times 0.648. There you go. It's not even 6,000, not even half a ton. So, I mean, that's what I'm saying. By doing stuff like sealing ductwork and putting insulation on there, this really shows how much you can actually reduce your lossage and your heat gains in your home just by fixing this. I've always said that the ductwork is our main problem. Our units are fine. Like I said, it's just the houses and the ductwork where we need to work on. All right, final factor in this one before we finish it all up. It's the LGA cooling. All right, so they got 1.867. That's the number they got right there. Now we need to figure out how in the world did they get 1.687. So LGA, here's our LGA, and it says surface area adjustment latent gain for latent gain actual return side area divided by default return side area. So actual return side area divided by defaulted return side area. LGA gain. So like I said, if you had 95 and 51, it's 8.63. Okay, so we'll look at their chart here, and we'll pull a calculator out just to make sure everything's on this is what it says it is. Let's see if we can shrink that down a little bit. There we go. Get it in here where we can see everything on the screen together. All right, so it says actual return size area, and their return size area was 70, and divided by their default return side area. So they said their default return side area is 38, and there you go. They got 1.84. So a little bit of a difference. That's what I'm saying. Their numbers are not exactly right, but that's it. All you got to do is take, what is this, line 17 and divide it by line 18. Line 17 divided by line 18. Okay, so we're going to look at ours. Let's get rid of that. So line 17 divided by line 18. Sure, calculator's ready. All right, line 17 is 70. We're going to divide that by 36.4 because that's my line 16. So actual return area divided by that, and there you go, 1.923. 1.923. Now, since you're going to be dealing with some of these different things, there you go. There's that number again. It's basically this right here, because this also shows you the same thing. We was just taking the extra long way because it's not a shortcut unless you've been it the long way. There you go right there. Latent gain equals line 19. So whatever we got for line 19, we're simply going to transpose it right there. All right, now we're all done. Our final thing that we have to do is figure out the last step of this, which is basically just following our commands right down here and transposing them over to our J1ae. So let me make that a little bit smaller because that's going to get in the way if we don't. There we go. So line 11 factor times line 21. So line 11's right up here, so 0.22. 0, 911, 0.212, 0.212 times line 21 SA factor. Line 21 SA factor is 2.491. 2.491. We get this number right here. Net heat loss factor 0.528, because we're going to round to the thousandths. Okay, now we're going to do the same here over here on the corrected side, same thing. So we're going to go up here to line 11 factor. Line 11's right here, 0.73 times our line 21. Line 21's right here, so 0.648. And we get much smaller number, 0.047. A much smaller number than this one. You can see how the corrected and the uncorrected, how this is actually starting to make a huge difference on what our total lossage will be from a sealed set of ductwork to unsealed. So now we're moving on to the next one. And basically line 12 factor. Line 12's right here. So this one right here. Let's go ahead and put an arrow up there, just for fun. So that way we keep on the right one. So we need this one here times the line 21 factor, which is this one right here. So give me another arrow. And line 21's right there. So we will multiply these two together. So first one up here is 0.324 times 2.491. And there you go. We got 0. And there we go. 0.807. Okay. Okay, we're going to do this one over here. So we'll move these over here. So that way they're on the right. 1, 2. There we go. Alright, 0.111 times 0.648. And that'll round up to 2 right there. So we'll put 0.072. Okay. Final one here, we got line 13 gain times line 22 LGA adjustment. Okay, so we'll use our arrows. So line 13, we're going to use this number here. And line 21, we're going to use this number right here. So multiply these two together right there. 1026.059 times 2.491. And we get 2,555.913. Okay, now we're going to do the same over here. I'm going to use the line 21 and line 13 here. And this is where you get to see a real big difference. 232.14 times 0.648. And I'm going to do that one just one more time because I felt like I accidentally clicked a button. Times 0.648. There we go. So we end up with just a mere 150.427. Okay. So these are all our numbers, and like I said, now I'm gonna just get rid of that one. We got to change some numbers over, so we got, like I said, heat, cooling, and some other factors here. So like I said, these numbers here, we'll deal with them first. So we got net heat loss factor. It's got to go to the J1ae. So we'll just put these all back up in here, like I said. So we're going to have to take all these numbers, these three numbers here, and move it over there. Okay. Now the corrected, we'll see where it goes. But that's it. Like I said, that's pretty much it for worksheet G. Now all we got to do is go back to our original, the Vatilo House in Birmingham, Alabama. And we got to transpose these numbers over. Now we're going to be down here in the heat loss, heat gain area. And once again, just for reference, we're going to do this. I'm going to hit save so that way I don't accidentally lose anything. We'll close some of this out so we clean up our workspace here a little bit. Get rid of that. We don't need to survey anymore. So we're going to go back to our Vatilo House here in Gulfport. Like I said, now we're dealing with these parts right here. So all these numbers down in here, right along this line, we've done subtotals, so now we need to figure out what information do we need to transpose over here actually to the other side. Just scooch these out of the way. So right here on this line, right below line 14, so 15 on down, we're going to try and finish up filling out this information right here. So the first thing it has a construction number with the insulation, the leakage rate, and duct surface area adjustment. Okay, so we're going to do the same thing on ours. Go to Birmingham, Alabama one. And we're going to try and fit all of that big, huge, massive amount of information in this little tiny area. Now this number right here, the 7A, that should be actually 7A-AE, because that's the actual table we're using on this one. R4 value, because we're doing the uncorrected, because that's actually what's installed in there. The leakage rate was 0.35/0.70, and with duct surface area adjustment. I'm just going to put SAA in there. Okay. Next thing, these factors, is 0.46 and 0.81. Where did they get these numbers from? We're going to go back to their worksheet. Worksheet G here. See where they got that. 0.76, 0.41. Let's just look for the first one right here, which is your factors. 0.46. 0.46. Where did they get 0.46 out of all of these here? 0.46 and 0.81. So these two numbers here, they just kind of rounded it up. We're going to keep ours at thousands. Okay? So we go back to our worksheet, bring it up, and ours is 0.528. So that's going to go for our heating right here. 0.528. And for our cooling, it should be 0.80 or 81. Because that's going to round up. We're going to put it in as it is, 0.807. 0.807. But that's where they got those factors from. Okay. Moving over to the next one. Now we got some numbers here. Where do they get the heat and the cooling load for all this from? Alright. Let's bring them back over here. So they got their latent gain. This is another number that's down here at the bottom, 2488. 2488. I'll close ours for a minute. 2.488. Let's see where they put that. Latent for duct and unconditioned spaces. So that number right there is going to go down here on our base number down there. Down out of the way. Bring back up ours. We need to look and see what ours actually had. Let's close some of this so we're not working all over ourselves. So we got 2555.938. So that's going to go right here in 24. 2555. point, slide over just a little bit, 913. There we go. Alright, so now we got some numbers here. We need to figure out where did they come up with all these numbers right up in here. So we got our BTUs for heating and BTUs for cooling. Alright. We're going to close our sheet for right now. And we're going to bring theirs back up. Because like I said, I want you to understand where they pull some of these numbers from. So we're going to have this sheet here. And we're going to go ahead and close our sheet. And we're going to bring their sheet back up. And see where they got some of this information from. Like I said, so 9,147 and 9,973. Where do they get these numbers from? Well, let's see. Where could this number have come from? So where do they come up with these numbers? Basically, looking at these charts, you got 0.46 right here, that's your heating. Like I said, this right here would be your cooling. So we're just going to multiply. Let me move some of this up out of the way here so we can make it a little bit easier to see. There we go. So basically we're going to multiply this number right here, the 0.46, times that number right there. Okay. So if we got, move this over here, got 0.46 is what they got, 0.46 times, and they got 19682. You come out with around about that number. Now this number here, like I said, I'm sure there's more digits there that they didn't show, but that's basically what you're going to do. You're going to multiply that number there times that number right there to give you this number. This number times this number to give you this number times this number to give you this number. Okay. So let's look at ours. We'll get rid of both of these out of the way. There we go. Clear out our calculator. So we're going to bring up our worksheet G, and we're going to bring up our Vatilo House here. So we got everything we pretty much need on here. Like I said, we're sitting here at 22,000 for heating, 12,000 for our cooling, and we're just going to multiply them by these factors that we came up with. And that'll give us our latent load, or our cooling, heating, lossage, surface area adjustment right up in here for duct lossage. We got 22,855.122 times 0.528. I'll make this a little bigger so you can see a little bit better. Move the calculator over. That bigger so we can see what we're doing. So once again, we're multiplying these factors times our subtotals. That's why you got to get the subtotal before you can go any further. And we end up with this. We end up with 12,067 point, and we're going to round this to our nearest thousandths again. So we're going to leave it at 4. So 504. Okay. And then finally, our 12,525.769 times this number right here, 0.807. And we end up with 10,108.296. Okay. All right. Now, just to finish this all out and everything, basically, you know, you got your subtotal. Anything up above this point right here, we're not worried about. Anything from here down, this is actually what we're going to be just adding together and everything. So we can go ahead and finish out this calculation. Ventilation minimum is 50, like I said, CFM for this job. So once again, we're going to look at our Vatilo House and see what they got on theirs. So, did it need any ventilation in this home? Did it need any engineered ventilation? No, it was no code requirement for it, so we got none on that. Okay. Next thing that we'll deal with will be the manufacturer performance data. So basically the blower, many blowers will tell you exactly how much heat. You can figure out the heat based off the kilowatts in it and everything. 1700 if no, 0 if yes, so ours is going to be 1700. And then finally, total sensible gain and everything, you're going to add this number here plus this number here, and if you add anything else down through here for our final total here, our cooling will be this number here plus the duct lossage plus the blower, and then that'll be this number right here. Okay, so we got none in 1707. So we'll get rid of these and go back to our original CFM for this job. Done. So that stays 0, those stay 0. If we have a blower, we're going to use the default 1707. That's just the heat created by the blower itself. Now our final step is add these two together for a total down here. You don't have to add it all the way up from the top all the way down the bottom because we already had our subtotal. So we're going to do 22,855.122 plus 12,067.504 to get us a grand total of 3,000. Let's bring our calculator back up and move it over here where we can type on it. So that makes our heating total, I'm going to go ahead and move that out of the way. Our heating total 3,492.626. And I just need to adjust this so it all fit in the box. There we go. Alright. Same for the cooling. We're going to just add this number here plus what we gained right there. So 12,525.769 plus 10,108.296 plus the 1,707 for the blower. And we end up with 24,341.065 for a grand total on that. Now we're not quite done. We still have to do the latent down here, so we're going to add all these up to get our total down here. Okay, but that is your total heating and your total cooling sensible right here and right here. And now we just need to add these up real quick right here. So starting right here at 957.393 plus 600 plus 2555.913. So we end up with, I'm going to move the box again, 4,113.306. Now, to put that into perspective to you, 6,000 BTUs, it's a half a ton of cooling. So in this leaking ductwork and leaking home that we have, or average, like I said, we're losing half a ton just converting moisture getting in the house into actual, BTU lossage. Because we're using the BTUs that we would have been using to drop the temperature of the air to actually convert steam, vapor in the air into liquid. But these are your final calculations. Like I said, this number right here is your final heating. This is your final cooling sensible and final latent sensible. And basically you're going to add this one to this one. And we'll go ahead and add that, 24,341.065. So 28,500, we'll just go ahead and say 28,500 for cooling, 34,000 rounded up 35,000. 35,000 for heating, 34,000, 24,500 for cooling, and that'll be the numbers that you actually use to try to determine your equipment size. Appreciate you watching the video, and I hope to have some more up on some of this information. But I hope this helps you in calculating your J manual.